All right, so here's the second type of special right triangle, which is a 45, 45, 90. And so when you're drawing a 45, 45, 90, you're just drawing an isosceles right triangle. So you're drawing the two legs so that they have the same length, and then you're just drawing the hypotenuse to connect them. So that's 45, 45, 90. All right, so 30, 60, 90 was equilaterally cut in half. Now we're just doing isosceles and right. Okay, so what happens here? So let's take a look once again at the patterns that develop. And let's talk about what happens if we start with a leg. So what happens if we call the side across from a 45-degree angle 1? And so if this is 1, that makes this side 1. And then we can go figure out what that side is using Pythagorean theorem again, right? So 1 squared plus 1 squared, right? A squared plus B squared equals C squared. Okay. And lock it in. And we know we just plug in. So 1 squared plus 1 squared is equal to C squared. And this is equal to 2, 1 plus 1, right? And then we just take the square root, and we end up getting the square root of 2. All right? And so what happens if we up that? What happens if we call this 2 now, right? So the side across in the 45-degree angle is 2. The other leg is congruent because it's isosceles, right? These are equal. And then we have to figure out the hypotenuse. So same thing, right? 2 squared plus 2 squared is equal to C squared. So that's 4 plus 4, which is equal to C squared, which is 8. And we have to do the simplest radical form again, or we're not going to see the pattern. So when you take the square root of 8, it's really 3 2's. We pull out a 2, and we get 2 radical 2 for C. So let's up it. Let's say we jump up to 5 this time, right? So if this leg is 5, so is the other leg. They're both 5. And so we end up getting 5 squared plus 5 squared is equal to our hypotenuse squared. And these are both 25, right? Which is actually 50, 25. And then we bust out the square root. So the square root of 50, if you remember, is 2, 5, and 5. 2, that's 5, that's 10 times another 5. So we're taking out the 5's. We get a 5 outside and a 2 left inside, and we get 5 radical 2. And so hopefully you're seeing this pattern starting to pop up, right? Which is whatever I choose for the legs, the hypotenuse is that leg times radical 2. All right? So once again, what happens this time if you start with the hypotenuse that we know? What if we know this side instead? So what if this is 3? Now we have to work backwards to get this. So if this is 3, how do we get this? And so here, we're going to have to call these two things x, right? I don't know what they are, but I know they're equal. So don't do a. So when we do a squared plus b squared equals c squared, now the legs actually have the same value. So we're going to use the same variable for both. All right? And so we get 2x squared. Actually, you know what? Let's just use an even number. Well, you'll see why in a minute. So instead of 3, let's call this 4. So if this is 4 squared, we're going to get, remember, x plus x is 2x. So 2x squared is going to be the result when we do x squared plus x squared. And this is equal to 16. The reason I did an even number is because I'm going to divide by 2 here. That's why I did an even number, okay? We can take a look at odd numbers, but we'll stick it even for now. So now we'll get x squared is equal to 8. All right? And now I got to take the square root. And I end up getting x is equal to 2 radical 2. So if this is 4, all right? So 16 divided by 2, 8. We get, remember, we get the 3 2's. We did this earlier. We take out a 2, we get 2 radical 2. So that is the length of the leg. All right? And so, well, let's pick something easy, right? What if I call this 1? Okay? So what happens now? So if this is 1, then we refer to these as both x. So it's just x squared plus x squared is equal to 1 squared. This is 2x squared. And then I divide by 2. So I get x squared is equal to a half, and then I take the square root. Now, when you square root a fraction, you can actually break the fraction up into the numerator and denominator. So what happens is you get 1 over the square root of 2, and you can't keep this as 1 over the square root of 2. You actually have to what's called rationalize, which means I need to get rid of the radical in the bottom. And remember, how do you get rid of a radical but by squaring it? So I'm going to multiply both top and bottom by radical 2 by squaring it. Remember, I'm multiplying by 1, and we get radical 2 over 2. All right? So this is 1 radical 2 over 2 for the legs. And if you look, that actually is what you got here. If we do 4 times radical 2 over 2, it's 4 radical 2 divided by 2, and this cancels out and gives you 2. So that's actually where that came from. So this pattern actually holds, okay? Where if you know the leg, let's say is 3, remember we're going to do that earlier, right? So it's x squared plus x squared equals 3 squared. This is 2x squared is equal to 9. We divide by 2, so we get x squared is equal to 9 over 2. We take the square root, and x is equal to 3 over the square root of 2, right? We're taking the square root of 9 and the square root of 2, and then we rationalize, and we get 3 radical 2 over 2, which is the same thing as 3 times radical 2 over 2. So this pattern stays. If this is given, we just take that and multiply it by radical 2 over 2. And that's our leg. And so those are the rules for 45, 45, 90. So the first one is, okay, given a leg, and this is really the one that you can stick with. If you remember this one, you should be good the whole time. That if it's x for the leg, x, then it's just x times radical 2. Okay? And if you're given the hypotenuse, you can always just use Pythagorean theorem. There's nothing wrong with that. Okay? But there is a pattern. So if we're given the hypotenuse, we're going to get x for the hypotenuse, and then it's just x radical 2 over 2. Okay? X times radical 2 over 2. That's the rules for the hypotenuse and the leg. And so that's it. So the next part of this is just doing some work. We're just doing a little bit extra here, right? So homework, we'll start it right now. So let's take a look. We have 45, 45, 90. So we have the rules. Remember, if this is y radical 2, remember the rule though, right? Given the hypotenuse, you just multiply by radical 2 over 2. So 18 times radical 2 over 2 is 18 radical 2 divided by 2. And now we just divide out. 18 divided by 2 is 9, so we get 9 radical 2. That's it. If you want to, just use Pythagorean theorem. Y squared plus y squared equals 18 squared. This is 2y squared is equal to, let me double check 18 squared. That's 324. We divide this by 2. So y squared is going to equal 162. And then we take the square root. And so if we do the factor of 162, we're going to get 4 3s and a 2. So y is equal to 2 and then 4 3s. So we're going to circle. We're going to take out both sets. So we get 2 3s outside, 3 and 3, a 2 left in, and there's where the 9 radical 2 comes from. Okay? So once again, this is just a shortcut for that. Okay? All right. What about the next one? If this is 36, remember the rule. If this is x, this is 2x, and that's x radical 3. So if this is 2x, all we have to do is divide by 2. So 36 divided by 2, and that's 18. Okay? If you forget, just SOHCAHTOA, guys. SOHCAHTOA, right? If I look at the 30-degree angle, right, this is opposite over hypotenuse. So I could do sine of 30 is equal to x over 36. I can cross multiply and solve. You don't have to use the rules, but I'm telling you, it's just a shortcut. It makes it easier. All right, for number 3, we have x radical 2. Remember the rule, it's y, and then y radical 2. So if here's 11, radical 2, that means these are just 11. Okay, that's it. And then same thing with this one. So if this is 14, remember the rule. If this is x times radical 2 over 2. So just 14 times radical 2 over 2. 14 and the 2 reduce to give you 7. So we get 7 radical 2. That's the shortcut. That's it. Okay? So keep working on these. The homework tonight is to finish. So if you want to go through and try, and then I'll post the answers online later. All right, guys, that's it.